Alright guys, welcome to a video on similar 3D figures. Before we jump in, let's remember what similar is. Remember, similar means two things that have the same shape but have different sizes. So if you take a photo and you zoom in on the photo, you end up with a larger picture of something, but it's still the same shape, right? So when we're dealing with similar 3D figures, we're talking about two shapes that are the same, just one is bigger than the other. Now, there's a special rule that goes with this similar 3D figures, and that's this one right here that's written down. Side ratio A to B, area ratio A squared to B squared, volume ratio is A cubed to B cubed. Now, this looks kind of complicated, but it's really not. In fact, we can actually write it just like this. Side, area, volume, okay, SAV, and so every single problem is going to follow this format. Side is A to B, area is A squared to B squared, and volume is A cubed to B cubed. So that should be a 3 and B cubed, just like that. Now I'll show you how these problems work. It's really quite simple. So let's take a look. So this one, we have two similar cylinders. They want the side, area, and volume ratio. So what I'm going to do is I'm going to set this thing up. My side ratio is just 3 to 7. This is my A number. This is my B number. Now my area ratio is A squared. So A squared is 3 squared, or 9. So my area ratio here is 9. And my B squared is equal to 7 squared, which is 49. Okay, so my area ratio is 9 to 49. My volume is going to be cubed, right? A cubed to B cubed. So A cubed is equal to 3 cubed, which if you type in a calculator, that's going to come out to 27. Your B cubed is 7 cubed, and that is going to come out to 343. Okay, 27, 343. And you can always use Desmos to help you do the cubes and the squares. All right, let's look at another example. Notice in this example, again, they ask for the area and volume ratio. So again, on the side, I'm just going to write SAV. My side ratio is 6 to 8. Now, before I write that down, the one thing I need to look out for is, can I reduce the numbers? And if I look at 6 and 8, I can reduce those. That reduces down to 3 to 4, right? My side ratio is 3 to 4. And now let's do the area. We're going to square both of them. That's going to be 9 to 16, 3 squared and 4 squared. And then volume. 3 cubed is 27. 4 cubed is 16 times 4, which comes out to 64. So there you go. There's the answer. Here's your area ratio. There's your volume ratio. Let's look at one more type of this problem. This time they give us that the size of the second cylinder is 2 times as large as the first cylinder. So we could think of this as 1 to 2. My ratio is 1 on this one side, doubled on the other side. So again, they asked for area and volume ratios. These should be a breeze. My side ratio is 1 to 2. I want to square 1. 1 squared is just 1. 2 squared is 4. And then 1 cubed. Remember, when we do cubed, we're always going from the side down to the volume. We're not cubing the area, we're cubing the sides. 1 cubed is 1. 2 cubed is 8. Just like that. Okay? So there you go. If we are looking for an area or a volume ratio and we start with the side, we're going to go down. We're going to take squares. We're going to cube to get down to my areas and volumes. Now there's one other way this problem can show up. And it looks something like this. What if I get the area, or what if I get the volume and I need to get back to a side? And all we're going to do is we're going to go in the opposite. Instead of squaring or cubing, what I'm going to do, if I'm going from the area to the side, remember my little chart, area is A squared, B squared, right? So to get rid of the squares, what I'm going to do is I'm going to take the square root of both of these numbers. The square root of 25 is 5. The square root of 64 is 8. So my side ratio here is 5 to 8. So our side ratio should always be smaller numbers than our area ratios. If you get really large numbers like 4 or 5-digit numbers, then we know we went too far, we went the wrong direction. Or if you end up with a decimal, it means you probably did something wrong too. All right, last example here. Here we're doing a volume ratio back to a side ratio. Remember, our volume ratio is A cubed and B cubed. Okay, so to get backwards, instead of doing a square root, I'm going to do a cube root. And again, if you look on Desmos, you can find the cube root option. So let's take a look here. It's going to look something like a square root with a little 3 on the side. Let's see if I can get a 3 there. It's going to have to be close enough. And take a cube root here. So if I take the cube root of both of these guys, cube root of 1 is 1, the cube root of 8 is 2, my side ratio is 1 to 2. So if you're going side down to area or volume, you're going to square it or cube it. If you're working the opposite direction, you need to take the square root or the cube root. This wraps up the lesson on surface similar areas. You can go ahead and try some of the problems now.